This is A2 X-Intercepts examples. So let's take a look at our graphs right here. So for this first graph, of course, an X-intercept is where our line or our function crosses the x-axis. So we have our line right here in blue, and it crosses at x equals 1. So that would be our x-intercept. Okay, looking at this one right here, we have our line. So we're going to see where it crosses this x-axis right here. Okay, and it crosses at the point x equals 0. So pause the video if you need more time. Hopefully those aren't too difficult for you. Okay, let's take a look at these right here. So this first one is in slope-intercept form, y equals mx plus b. So to find the x-intercept, I know an x-intercept is wherever my y-coordinate is 0. So I'll set this y equal to 0. 0 equals negative 3x plus 2. Now I can solve for x. So I'll subtract 2 on both sides. Those cancel. I'm left with negative 2 equals negative 3x. Negative 3 is being multiplied by x, so I have to divide by negative 3. So these cancel. So I'm left with x equals negative 2 divided by negative 3. I know my negative sides cancel, so I'm left with 2 over 3, or 2/3. So if I had a graph on the x-axis, this line would cross at x equals 2/3. So this next one is in standard form, so I'll do the same thing. I know my x-intercept is where my y-coordinate is 0. So 4x minus 5 times 0 equals negative 10. So let me simplify this. 4x equals negative 10. To get the x by itself, I can divide both sides by 4. 4's cancel, so I'm left with x equals negative 10 over 4. Well, negative 10 and 4 are both divisible by 2. So I can rewrite this as negative 5 over 2. And we can just leave it like that as an improper fraction. Okay, let's move over to this one. So I'll set my y equal to 0. So I have 0 minus 3 equals negative 6 x plus 1. So I'll distribute this negative 6. So over here I'm left with negative 3 equals negative 6x minus 6. So now I know I need to solve for x. So I can add 6 to both sides. When I do that, the 6's cancel over here, so I'm left with negative 6x. And over here I have negative 3 plus 6, which I know is 3. To get x by itself, I will divide by negative 6 on both sides. So negative 6's cancel, so I'm left with x equals 3 divided by negative 6. Well, 3 and negative 6 are both divisible by 3, so I know I can rewrite this as negative 1/2. So that would be my solution for my x-intercept. Okay, back down here we've got another slope-intercept form equation, y equals mx plus b. So I'll set y equal to 0. Okay, now I can just solve for x. So I'll add 2 on both sides. So these 2's will cancel. I'm left with negative 1 over 4x equals 2. So I have negative 1/4 x here. I'm going to rewrite that. So I now have 2 equals negative 1/4 times x. I could write as negative x over 4. Okay, because when we multiply fractions, we just multiply our numerators. So our numerator here would be negative 1, our numerator here would be x. So how do I get rid of this negative sign in this 4 on this side? Well, I know it's being divided, so I can multiply by negative 4 on both sides. So these cancel, so I'm left with x equals 2 times negative 4, which I know is negative 8. So that would be my x-intercept. All right, so let's move on to this next standard form equation. So I have 5x minus 2 times 0 equals negative 2. So if I rewrite that, 5x, negative 2 times 0 is 0, so I don't have to write anything. So I'll put equals negative 2. So to get this x by itself, I'll divide by 5. I'll divide this negative 2 by 5, because what I do on one side I have to do to the other. 5's cancel, so I'm left with x equals negative 2 over 5, which cannot be simplified. All right, last one. We have a point-slope form equation here. So just like I did up here, or actually what I did for the previous 5 examples, I'll just set my y equal to 0 in order to find my x-intercept. So I have 0 minus 5 equals 3 over 2 x minus 1. So I'll distribute this 3 over 2. So I'm left with negative 5 equals 3 over 2x minus 3 over 2. So what I have to do now, I have to add this 3 over 2 on both sides. So actually what I'm going to do here, I'm going to rewrite this process right here. I know I'm going to need a little bit more room, so let me do this right here. Again, please don't do this on your paper. Please just use an extra sheet of paper or any additional space you may have. Okay, so I know these 3 over 2's will cancel. So I'm moving up here. I'm left with 3 over 2x equals, so I have negative 5 plus 3 over 2. So I know when I add fractions, I need a common denominator. So my common denominator here would be 2, because I have negative 5 over 1 and 3 over 2. So I have 3 over 2, which means I have to multiply this negative 5 over 1 by 2 over 2. So if I multiply by 2, I get negative 10 over 2. So I know this equals 2 will be my denominator, and I have negative 10 plus 3, which gives me negative 7. So up here I have negative 7 over 2. And if you are very confused about that, just go through the math showing every step, and if you are still confused, just come grab me for help. Okay, so I have negative 7 over 2 equals 3 over 2 times x. So to get rid of this 3 over 2, I will multiply by 2 over 3, which means I have to multiply this side by 2 over 3. So that gets rid of my 3 over 2 and my 2 over 3. So I'm left with x on this side. And I have 2/3 times negative 7 over 2. So 2 times negative 7 is negative 14. And 3 times 2 is 6. So 14 and 6 are both divisible by 2. So I know x will equal negative 7 over 3. And no need to type that into a calculator. We are fine with improper fractions. Okay, so especially this last example, if things got complicated for you and you had trouble down here with the adding of fractions, just come see me. Okay, I can explain it in person. So now you have seen examples on how to find x-intercepts given a graph or any type of linear function. Now you are ready for x-intercept practice A, B, or C.